Good morning, everyone, or afternoon or evening, wherever it is you are located. I do have an announcement, and that is that the channel continues to grow. And that only motivates me more and more to continue to produce videos for you all with related to math. In this video, we're going to talk about something that you were probably, of course, I'm making an assumption, but I do a lot of inspections in schools, and I've never, at least from the schools I've seen, I have not seen this. These are the objective of the video today, of course, is to show you some mathematical truths that were either hidden from you or your instructors might not know them because they're not actual mathematicians. And unfortunately, we are living in an age where people who are not mathematicians are teaching math, which is in a comedy would be laughable, perhaps, but it really is a sad state of affairs that we have people who are, in many cases, I'm not saying everyone, but in many cases, completely unqualified to be even touching mathematics and contaminating our field in many ways. But I'm not going to get into that in this video. I will just show you some fundamental truths that from will save you a lot of time and will help you improve your calculations and your mathematical rigor. The first thing is that when an equation has a common factor, it is automatically the value of the variable is automatically zero instantly. So for example, let's say I gave you 2x plus 3x is equal to, and this is again a typical sort of, well, it's an easy example, but equals 4x. So what do they share in common here? They all have x as a factor. So on each side. So that means that instantly x is equal to zero. Done. Right? Now, look at the traditional way, or sort of how they're taught in school. You would have to bring it to the other side. You would have to bring the 4x to the other side and then set this equal to zero. And then, of course, you would do your manipulation. So I'll write it down here. Common factor in the terms in an equation, zero. Number two, what if we had one with parentheses? Let's say you had 4 parentheses x minus 1. And we're going to set that equal to x minus 1. And at this point, you might be saying, well, but there's no common factor here. Well, yes, there is actually. X minus 1. You have 4 parentheses x minus 1, and you have an x minus 1. So you have a common factor of x minus 1 on both sides. And in that case, x minus 1, the factor itself, is equal to 0. And if x minus 1 is equal to 0, then that means x is equal to 1. Don't believe me? Try it. 1 minus 1 is 0. 0 times 4 is 0. 1 minus 1 on the other side, 0. Done. Next one. What if you have fractions? Right? What if you have 1 over 2x plus 1 and we're going to set that equal to, well, actually, let's add plus 2 over x plus 3. And we'll set that equal to x plus 1. Now, you may be saying, what do I do here, right? What's the secret here? Well, again, these are fundamental truths. If you have fractions, I always recommend when you have fractions to, depending on the fractions you have, but in this case, I would cross multiply because you have on the left, you could see if you cross multiply, you could see that the numerator is going to become 5x plus 5. And I'm assuming you know how to cross multiply and combine like terms, et cetera. So that's why I'm. And so now you have x plus 1 is a common factor, right? So that means that x plus 1 is equal to 0. Why, by the way, just to be clear, why is x plus 1 a common factor? Because 5x plus 5, the common factor here is 5. So we could single out that, take it out, and now we have parentheses, x plus 1. So because x plus 1 is a common factor, x plus 1 once again is equal to 0. And therefore, x is equal to -1. Done. So whenever you see an equation that has a common, like in this case, in these cases, you could automatically solve either by 0 or setting them equal to 0 and then solving for x. It saves you a lot of time. Now, what if your equation is product of independent terms? So the product, let's say you had an equation with parentheses on both sides. Let's do x plus 4 times x plus 6. And we're going to set that equal to x plus 3 times x plus 8. Okay, so it looks a little harder than what it actually is because what are the independent terms here? Well, the products of the independent term is always the constant, we could say. And so we've got 4 and 6. 4 times 6 is 24 on that side. Then right here, 3 and 8. The product of 3 times 8 is also actually 24. So you can always do this by inspection. You don't have it in every equation, but if you do have it, always check for things like that. So that means that because the product of the independent terms is the same on each side, x is equal to 0. All right? The next one we could do, another fundamental truth. What if we had something like 3 parentheses? You might say, well, that doesn't work for, well, no, it works. The laws of math work or they don't work. So you have x plus 1 times x. Let's say you had x plus 1 times x plus 2. And in the third parentheses, we'll make it x plus 3 is equal to, and then we can do x plus 1, let's make it fancy, right? X, put in an exponent in there. X plus 1 squared. Square that. And we're going to multiply that by, trying to think, x plus 6. All right, well, let's look at the constant terms. On the left side, you've got 1, 2, and 3. 1 times 2 times 3. That's 1 times 2 is 2. 2 times 3 is 6. What about on the other side? 1 squared, that's 1 times 1 times 6. That's also equal to 6. Aha, so automatically, that means that it's going to be 0. So going by what we said earlier, when we were talking about the common terms, now you have, if x is equal to 0, that means x plus 1 equals 0. And therefore, x is equal to -1. And you can, of course, always check, go back to the equation and check to see that this is working, that this is actually being equal to. So you can see, you see all this revealed with the laws of math. All right, now what about another truth of math? What if you have the sum of the denominators when you have fractions that have the same numerator, numerical numerator? So if you have the same numerator in your fractions, then you got to see what you can do with the denominators. What do I mean by that? Well, what if you had, like, for example, 1 over 2x minus 3? And we could do plus 1 over 5x plus 1. So here you have the same, we're going to set that equal to 0, just for example. So here you have the same numerical numerators. You have ones. So that means that, and we have a 0 on the right. So that means that 2x minus 3 plus 5x plus 1, the denominators here are actually going to equal 0. And if that is equal to 0, then that means that x is going to be 2 over 7. So what do you do here? You just add the denominators, plus 5x plus 1. And we're saying that that's just equal to 0. And if you combine the like terms, you have 2x and 5x, that's 7x. Negative 3 plus 1 is minus 2 equals 0. And therefore, your final answer is x equals 2 over 7. Done. You see, it didn't took less than 20 seconds. If again, I'm not saying it always, but train yourselves to look for patterns, to look for ways that you can manipulate equations creatively. Right? Let's do another one. What if instead of a numerical numerator, you have variables in the numerator? So, but that are the same terms. So let's say you have 3x over, I'll just write this one out because I don't like typing. I missed the chalkboard. So if you have 3x over x plus 1, and we're going to use the same term, 3x over x plus 2. Equal to 0. So again, in a situation like this, you just add the denominators. So you have x plus 1 plus x plus 2. X plus x is 2x. 1 plus 2 is 3. So you have 2x plus 3 is equal to 0. If you solve for x, you get x is equal to negative 3 halves. Or 0. All right? There are many other truths, fundamental math truths, but I thought that this would have been useful to you. In my next video, we'll talk about more. So I hope this was useful for you. If this was useful for you, I urge you to please subscribe to the channel. Please help us to continue to grow so that we can share math to students who are deprived in our system, in our educational system, and they are being turned into failures because actually what is failing is the educational system. It is an entire system that has failed our young people. It has failed countless generations. And I'm not going to give it a start date or an end date because there is no end date, but I am very concerned with what I am seeing. And so if you want to stop feeling like a failure and start to actually do maths and start to actually do things in a serious way, then definitely please subscribe to this channel because we're going to be sharing fundamental truths that no one else is teaching, and or at least not that I'm aware of. Again, it could be that some of you have a mathematician as your instructor, but I very much doubt it because if I do an inspection of the local schools and I go up and down the country all the time, I'm not seeing mathematicians in the classrooms. In fact, most mathematicians would rather not teach. I took a different route because my passion was to share mathematics with people because I wanted people to share the joy that I felt starting out as a math failure in school when I didn't know these truths, when I hadn't discovered the power and the freedom of mathematical laws, the freedom that mathematical laws give you. And so if this was useful, once again, please subscribe. Thank you for watching, and we'll be seeing you soon.